So yeah, we are going to start our workshop off here, very slowly, very nice and gradually, by creating ourselves a new project through Unity Hub, and that actually it will take a while, from like 5 to 10 minutes on like depending on the power of your computer. So we're gonna want to do that right at the beginning before we get into, you know, any of our pre-workshop chit chat. So you're gonna want to open your Unity Hub and click that new project button and make sure that the 3D template is selected. Name it whatever you like. Let's leave it as my project 1. That's pretty classic. And then hit create project. All right. So, my name is Max. I am the president of the Ottawa Game Dev Club, and I have been using Unity for many years now. So this workshop is just going to be a nice little beginner demo for Unity, a nice follow-along little workshop. We're going to make a nice, simple little game and teach you guys the basics of Unity's physics system, its scripting system, the editor. Just a nice little all-around lesson. So, let's see. Yeah?
Sorry, I was at the last workshop. Is there any sort of new content, or should I?
Well, we're going to be, it's a different game this time, so there's going to be a little bit of a different stuff covered. Mostly the same basics. So, yeah. And yeah, if you have any questions at any time, feel free to raise your hand, or if you're behind me, or if I'm not seeing your hand, maybe one of my club mates here will see it and then tell me, and then so yeah, basically don't be afraid to ask questions because we have plenty of time here. So yeah, I hope you've all created your project. As you can see, ours has been busy creating the project for 1 minute and 25 seconds now, and the bar does not seem to be filling at all, but that's always how it is. It's going to go from like 0 to full in like a couple seconds. See, look at that, already like a third of the way through. Yeah. Could I speak up? All right. That better? Man, it's almost right in my mouth. All right. Is that better? Okay, nice. Yeah, I have to be careful not to like turn my head while I'm talking also. So, oh man. Well, while we are waiting for our project to start, actually, I was going to open a test project. Well, why don't we just chat then? How many of you guys have made a game before?
Robert.
Yeah, yeah. Game Maker? That's pretty sick. That's pretty classic. Cedric? Yeah. What? Plug our club. Actually, yeah, it's a. Oh man, that's classic. That's vintage. But yeah. All right. Well, my editor has opened, so I suppose. Well, let's see. Let's get a show of hands from the people who are following along. Whose project has yet to open? Who's still creating their project? Most of you guys? All right.
I'm downloading the editor.
Downloading the editor. Okay, I think.
It's 5 gig download.
Is that step
Yeah.
500 kilobytes per second.
You might be a little bit behind then. Well, in that case, we'll give it a bit longer for everybody's projects to open because that's a pretty important step. And so in the meantime, I will take you guys on a tour through Unity's editor. All right, so you guys can see the screen. This is Unity's lovely editor window. Now I know it looks like a lot at first glance, and it is, and that's what makes Unity so powerful. But you know, you just gotta take it one step at a time, and eventually you will master it. Let's have a look around here. This big window in the middle of the screen is our scene view, and the scene, of course, is, you know, it's the theater stage that the the play of our game will take place on. You can right click in the scene window to enter like a fly mode where you can look around and use WASD to fly around. And it's all very nice. As you can see now, it's an empty void with a cool little skybox. That's Unity's default skybox and a couple of icons. And what these icons are is a camera and a light, which every Unity scene comes with by default. So now let's take a look over here at our hierarchy. What this box here contains is objects that exist within our scene. These are like each of these corresponds to each of these entries in the hierarchy corresponds to one object in the Unity scene view. So as you can see, under our sample scene here, we have our main camera, which corresponds to this little camera icon here. And as you can see, when we select it, a bunch of stuff pops up. We got these funny little arrows, and what seems to be like a what's that? Like a square-based pyramid projecting out of the icon, and that's actually the camera view. And you can actually see it in this little window at the bottom of the screen here, in the window in the bottom of the scene view. That's what the main camera sees. You can drag it around, but for our purposes right now, we can just leave it there. And then if we take a look at our directional light here in the scene, that is what else? It's a light. It just kind of lights up everything in the scene, nice by default. We can play with the settings if we like. We can play with the colors. And you'll notice that it actually doesn't do anything yet. And that's because we don't actually have anything for the light to shine on. So if we had like a cube or something in that scene, it would be turning all sorts of colors right now. Which reminds me, actually, we can create a cube. You can actually, in the hierarchy here, you can add new objects to your scene by right-clicking, and you get all these options. The ones we want are down here. You can create an empty object. You can create a 3D object. And then effects, lights, audio, video, UI. These are all, these aren't what we're going to be looking at today. We're going to be looking at 3D objects. Now, why don't I pause here and get another show of hands. Whose project is still opening? Yeah, a couple people. Oh. Yes. Template is the 3D template. Yep. Yep. All right, well, we have a couple people still waiting on the project to open, so anyways, any questions? No? All right, cool. Yeah, we can right-click here in our hierarchy view. If you hover over a 3D object, you can see you can add a cube, a sphere, a capsule, a cylinder, and more. So if we click cube, you can see that a cube appears in our scene and in our hierarchy. Right away, we can change the name if we like. We can change it to like Epic Cube. Of course, this doesn't change anything about it, just the name. And you can see that it actually generated way off in the distance there. And now, this will take us to our next window, which is over here on the right. This is the inspector window. You'll notice that it changes whenever we click on something in our hierarchy. You can see if we click main camera up here in the inspector window, main camera. We click our Epic Cube, well, in the inspector, Epic Cube. And the inspector, as the name implies, lets you inspect all of the components and qualities of each object in your scene view. And just looking at it right now, you can see our cube has a mesh filter, a mesh renderer, a box collider, and our camera, if we look at that, it has a camera component. We'll do figures, and then our light, well, a light component. And you'll also notice that each one of them has at the very top a transform component. So basically what these all are, what these all represent, is essentially Unity. Every object in your scene view is essentially a collection of components. So the components you have on each object essentially describe what it is and how it functions. The reason that each of them have a transform is the only component that they all share, is that every single object that exists in the scene view has to have a transform because it exists in 3D space. the transform component basically stores the position, the rotation, and the scale of every object in the scene view. So if you click on an object and start messing with the position here, you can, if you want to slide the values around, you can grab the, you can click on the X, the Y, or the Z and hold it and then drag left and right, and that, as you can see, it's shifting that cube left and right on the X axis of Unity, which is pretty cool. And of course, the same goes for the Y and Z axes, the rotations, and yeah, all the changes we make to the transform are reflected in the object in the scene view. And then these other components, we've got ourselves a mesh renderer. That basically is what makes this object a cube instead of nothing. Every component you'll notice, except for transform, go in here mesh filter, but that's a whole nother story. Most components will have a checkbox here that allows you to enable or disable them. So if we were to disable this mesh renderer, oh, our cube's gone. Of course, you'll still see a green outline here in the scene. And what's that? That's the box collider that a cube comes with by default. And of course, colliders define the bounds in which each object will like collide with another object. It's like the hitbox, basically. And of course, we could do something psychotic. We could put any shape of collider we want on any object. So even though we take the box collider off, we remove that component, it's still a cube. It's still visually a cube, you know. But we can actually add something like a sphere collider, and it might be a cube, but its collider is in the shape of a sphere. Isn't that crazy? Anyways, so yeah, these components define the properties of an object. You can add them, you can remove them, you can do all sorts of stuff with them. It's very cool. Anyways, all right, hopefully last show of hands, anybody still waiting on their scene to load, their project to open? No? All right, I guess that means we can begin. Whoa! All right, so the game we're going to be making is a very simple little physics-based game. It'll let us play with the Unity's built-in physics system, which is very nice and very, very easy to get started with. I forgot what I was going to say about it. I had something to say about it. Oh yeah, it was inspired by I don't know if you guys ever played WarioWare, but there was one in like the Wii, the WarioWare game that was on the Wii. It was like you played as this little platform and you had to catch falling blocks, and if any of them fell, or like the tower blocks you built fell over, then it was game over. And that seemed pretty nice and simple, so I thought we could recreate that in our workshop. And you'll see it's actually pretty fun. So why don't I'll delete my cube here. Let's get back to an empty, well, I guess not empty, but a default scene with our camera and our directional light. So you can right click your cube here if you happen to create one, and just hit delete right here. So, well, the first thing we're going to want to do is create our, oh wait a minute, I just realized I forgot to talk about the project window down here at the bottom, and this one's pretty simple. It won't take long. It's basically just all of the folders that make up your project directory and all the files that exist within them. So you can see right now all we have is our assets folder, which contains our scenes folder, and our scenes folder contains our sample scene, which represents this scene that we're in right now. And you can have multiple scenes within your game. You can transition between them, but that's something for another day. We're just going to stay within the bounds of our sample scene today. So let's get started. Let's right-click in our hierarchy and create, under 3D object here, we're going to create ourselves a cube. And you can name it whatever you want. I'm going to call it platform, because this will be the object we are controlling. It'll be a little platform on the bottom of the screen that we can shift side to side. So right now it's just a cube, and it did generate it all the way over there. We want it to be right smack in the center of the game world, which we can make that happen by going over to our transform component in the hierarchy and just setting all these values to 0. So We can change our position's X value to Z. Okay, wait. 0. Usually you click on the field once and it highlights the entire number, so it's pretty easy. And then our Z value to 0. And there it is, right smack in the middle of the game world. And, well, we could have leave our platform like this, but it'd be nice to make it a bit bigger. So why don't we make it like nice and plate shaped? We can extend it out on the the x-axis by grabbing X here in the scale and dragging it out. Let's say maybe 10. Looks nice. And why don't we make it a bit thicker on the z-axis here as well? And yes, that's a nice looking little platform. Now, for the first time, we are going to look at our game view. You might recall when we had our main camera, when we were looking at our main camera in the hierarchy here, you can click it and it will show you what the main camera is seeing. You can also see that by going up here to this tab, which is the game view, which shows you what the player is going to see when they play your game. Right now, it's just showing the camera view. And indeed, it is seeing our platform and nothing else. And we can actually, right now, we can hit this big play button right at the top of the Unity editor to play our game. Now, nothing's going to happen because we haven't actually added any behavior for this cube. It's just going to float there for eternity. So let's change that. You can hit the play button again to exit play mode. You can also hit this pause button to pause the game, which is very helpful. You can actually edit the scene in real time if you want to change values for testing and stuff like that, which is really cool. And then when you exit play mode, all the values reset to what they were at the start, so you don't need to worry about messing up any of your work. It's a very neat feature. But for now, we want our platform to catch a falling block. That will be the main foundation of the gameplay for this little game we're making here. So why don't we make first a falling block. Let's right-click in our hierarchy, hit our 3D object, and add another cube. I'll just leave it, call it cube. We're going to want to reset its position over here in the inspector. We're going to want to reset its position on the X, Y, and Z axes to 0 again. And then let's just go ahead and position it. You can either change the Y value in the inspector here, or grab one of these arrows, the green one, in the scene view to move it. It's very handy. Let's drag it all the way up here, and then we're going to want to make it fall. This is just going to be a test block. Like later, we're gonna make them spawn randomly on different sides of the screen and everything. But for now, we just wanna test to make sure it can fall and land on our platform. So we're just gonna drag it up there, and well, if we were to go into play mode now, we just have 2 cubes frozen on our screen because neither of them actually have any physics yet. Neither of them interact with with Unity's physics system at all. And the way that we change that is, of course, by adding a component. So let's make sure our cube is selected here in our hierarchy, and let's go over to the inspector on the right, and let's scroll down to the bottom there. We don't need to worry about all these other components that are on it already. And you see this button at the bottom of the inspector, Add Component. We're going to click that. And in order to get this object to have gravity and collide with things, we're going to need to give it a rigid body component. So you can search in the search bar that comes up, and it'll point it out for you. And then you can just click it, and pow! Our cube now has a rigid body. Isn't that great? And we can actually hit the play button to see the fruits of our labor thus far. And hopefully it will not be as static as the last time. Oh. Hey! Woo! Congratulations. We have created life. So the cube falls and it lands on our platform. That's fantastic. But of course, in order for a game to be a game, there must be input. The player must be able to control something. And so let's get some controls on this platform. Let's make it so that we can move it left and right with our arrow keys. So we're going to want to click the platform in our hierarchy, and then look over at the inspector. And wait a second, what component do we add if we want to move something by input of the keys? And I tell you, such a component does not exist readily. We are going to have to we're going to have to write some code. So in this component search bar that comes up, we're going to want to write the name of the script that we're going to create that will allow us to control this platform. So let's keep it simple and call it platform controller. And then you'll see that this component does not already exist. There's no component called platform controller. So our only option is to create a new script. So we're going to click that, and oh, new script. It's already taken the name platform controller that we typed in. And now we're going to hit create and add. Boom. And now you'll see that, well, right now it's script in brackets, but Unity basically needs to reload its script stuff. And then now if we check platform and scroll down, platform controller script. Whoa. Of course, it doesn't do anything yet. We haven't added any code to it. And the way that we can add code to it is, well, first of all, I hope you guys have some kind of code IDE installed on your computers. If you don't, I'm pretty sure you can just use like Notepad++ or something if you're really in a jam. My editor of choice is Visual Studio. You can actually go up here into the settings bar and hit edit, and then all the way down in preferences, it's quite the drop down. Preferences, you can go down to external tools, and the very first option, external script editor, you can change your the IDE that Unity will use by default to open and edit scripts. So I'm going to change that to Visual Studio Community 2022 because I like Visual Studio. And Visual Studio actually, when you install it, there is a library you can install that is specifically for Unity, and it basically has like autocomplete for like Unity classes and stuff. And oh my god, if you intend on continuing to use Unity, please get it. It makes the coding experience like twice as nice, or perhaps thrice. So now that we've set our editor of choice, we're gonna click our platform, go over to the inspector, scroll down all the way to our platform controller script that we added, and then on the right here, you can see these three dots. And every component has these three dots. They contain stuff like reset, which resets all the values. You can remove the component. You can move it up or down in the inspector view. But for a script, you can see that at the very bottom, you can edit the script. And so yeah, we're going to click those three dots in the corner and edit our script. So while this loads, I would like to take this opportunity to ask those of you who are following along, we run into any trouble yet, or all good? I will take that as an all good. All right. Windows Defender Firewall has blocked some features of this app. Communicate on public networks. I don't think we need to enable that. It's a little. I've never gotten this message before. Well, anyways, you can see that our script has opened. Look at that. Beautiful, isn't it? So this language, if you haven't seen it before, you might think you've seen it before. This is C#. And how many of you guys have experience with Java? Yeah? Yes. Well, if you don't also have experience with C#, let me tell you, you already have experience with C# because it's very, very similar to Java, and I doubt that through the course of this workshop we will even come across like anything that meaningfully differs between coding in C# and coding in Java. Next, you'll see that the script has generated with some default methods here. You'll notice that our platform controller script automatically inherits from MonoBehavior, and that's because MonoBehavior is the class. It's built into Unity. Every component that attaches to a game object in in the Unity scene view, every component has to inherit from MonoBehavior. So since platform controller is a component, we attached it to our platform, remember, it has to inherit from MonoBehavior. And because it inherits from MonoBehavior, we get a couple neat little methods, start and update. And there are actually a whole ton of other useful methods that we inherit from MonoBehavior, but these are the two big ones. Basically, they even come with fancy little descriptions for us. The first one, start here, is called before the first frame update, which basically means it's called as soon as you hit play mode or as soon as the player starts the game. Or basically as soon as the scene is loaded in the case that you're using, multiple different scenes in your game. And then an update is called once per frame. As simple as that. So our platform, we want it to move left and right. We want it to move left and right when we hit the left and right arrow keys. So we're gonna add a variable here, just a nice little private class variable here. Actually, let's make it public. We're gonna make a public float for move speed. This is just gonna be how fast our platform moves. Let's just call it 5 for now. Let's just call it 5. And that's all well and good. Actually, you know what? Why don't we save our script? You can hit Control S to save your script, and let's go visit the Unity editor again and see if anything has changed. What is? Oh, this was from something else. Never mind. But yeah, so if we go back to our editor after adding that public variable to our script, you scroll down and look at our platform controller, and what the heck? There's a move speed field here that we can change now. And yes, that field corresponds directly with the public float that we declared in our script. So you can change that whenever you like in the editor without having to go into your script, which is very, very nice. Very, very fun little feature. And this will happen with all of the public variables that you create. If you make it private, it will not show up in the editor. So let's continue. Basically, we're going to be wanting to check for left and right arrow key presses every frame. So recall update is called once per frame. So we're going to check in there, and we are going to create ourselves a little if statement here. So Unity has a very simple system to check for inputs. You use Unity's, what else? Input library. And oh wow, we got code suggestions on. Okay, well we won't be needing those, but okay, that's okay. We'll ignore the code suggestions. We're gonna want to do input dot get key. Well, actually, I guess just get key. Basically, get key triggers every frame that a key is held down, and the way we tell it which key we want to check is held down is in the brackets here. We use Unity's built-in key code enum key code dot, in this case, let's do left arrow. And there's a key code dot A, there's a key code dot B, key code dot space, there's a key code dot everything. So it's really that simple. It's not like JavaScript or something where you have to take into account different browsers or different ways of capturing input. It's just the one. It's very nice and simple, very elegant. And now in this if statement, basically this is going to trigger every frame the left arrow key is held down. So we want to move our platform to the left. So how in our script can we get a reference to the platform object's position? Well, I tell you, it is simpler than you could possibly imagine. Basically, MonoBehavior, recall that it's the that script that all component objects inherit from, has a built-in variable transform, and this essentially refers to the transform component that is attached to the object in the hierarchy view. And if you remember, every object in the hierarchy view has a transform. So if we use transform, if we refer to transform in our script here, if we look back at the editor, since our platform controller is attached to our platform, that variable that we're using here is referring to this transform component attached to our platform. Again, very elegant. and we can access the position of our transform with transform.position, position with an N. And yeah, it's as simple as that. And the way that we change the position is we can add to it a vector3 value. And a vector3 is what else? It's a vector with an x value, a y value, and a z value. You know, vector, direction and magnitude and all that. We want to move it to the left, so we're going to have something in the x value of the vector, but the y and z values we're going to leave as 0. So we're going to, oh, wait a second. We got to create a new vector3. And in that vector3, we are going to put the x value as our move speed and y and z values as 0. And this will change our platform's position by 5 unity units each frame. And 5 unity units is actually a huge distance. And the reason that I set move speed to such a huge distance immediately is because actually there's something else we need to take into account when we're doing any kind of movement in the update function here. So update is called once per frame, right? But the frame rate on a monitor can vary really substantially, like depending on the power of the computer, the power of the monitor, right? The well, I don't know, games can run pretty slow if they have like really high graphics demands and your computer is not strong enough to handle them, right? So we actually need to correct for frame rate in order to ensure that the platform moves the same relative distance over time on anyone's computer. And it's actually also really simple to do that. We can actually multiply this distance that we're moving each frame by time, which is a built-in library, dot delta time. And time.delta time is the value of the time that has passed since the last frame. So when you do all the math, basically that means no matter how many frames have passed in 1 second, it means that the total amount of distance covered in that 1 second is equal to move speed. So basically this means that on any computer, on any frame rate, our platform will now move 5 unity units a second. So let's get this saved. Let's go back to our project and let's hit play mode and see what happens. So our cube will fall, and if we hit our left arrow key, whoa, well, it moves to the right. But it moves. That's it, we've officially created a game. There's input. Woo! But don't worry, there's more. So the issue here is that, of course, in our left arrow, when our left arrow key is pressed, we are moving the x, or the position of our platform a positive amount on the x-axis, which means we're moving it to the right. So we can do minus move speed times time.delta time. And now we want to add that right movement as well. We can copy this whole block, paste it, and just change keycode.left arrow to keycode.right arrow. And take away that minus that we just added so that it will actually move right this time, because we do want it to move right this time. And now if we check our game, we hit play, the cube falls, and we can move our platform both ways. Excellent. So this is basically the extent of the control that we are going to allow the player in our game. You'll see an issue right away, is that the cube on top of the platform is not moving with the platform. And that is because the cube is moving via the physics engine, Unity's built-in physics engine, and our platform is moving by having amounts directly incremented to its position value. So it's not interacting with the physics system exactly, although it does still have a hitbox, so the cube can like fall onto it and stay on it. And how are we going to deal with that? Well, we could give the platform a rigid body, and instead of using transform.position plus equals, like our vector, we could use like physics. We could use like physics methods, like add force to the platform instead, but then we'd have to disable gravity. We'd have to do a whole bunch of other stuff. As with basically any technological problem, when you have a new feature that you want to add to a game in Unity, there are a bunch of different ways of handling it. Some are easier, some are more expandable, some are more effective in the long run. We're going to use the easy solution. That is maybe not the best if you're going for a full game, but is pretty swell for our purposes right now. And so here's what I'm thinking. Our cube, we're going to make it so that when it impacts our platform, it becomes attached to the platform, and it will receive the same movement values left and right when the platform moves left and right. And that way we can kind of fake, like dynamic friction, and like fake that the block is like following the platform's movement. And of course, game development is all about trickery. So this is an important exercise. All right, so how are we going to do that? We need to, well, first we're going to create a script for our cube, because it's going to need to tell when it hits the platform. And for that to happen, we need to give it some custom behavior. We're going to need to code some behavior for it. So click your cube in the hierarchy, go over to the inspector on the right. Oh, hold on a second. Go over to the inspector, scroll all the way down, add a component. Let's call this script block. New script, create and add. And we can open it as soon as it loads. So we don't really need to worry about anything in start and update here. There's another, remember when I said there are other useful methods that we inherit from MonoBehavior? One of them is on collision enter. And that's basically public void on collision enter, open brackets. Oh, okay, well, it filled it for me. But basically, it takes a parameter of type collision called collision. And essentially what this does, this method is called whenever this object impacts another object in the game. So this will be called when our cube impacts the platform. And so what we want to do is we want to check in this method, we want to be notified when the cube impacts the platform, and then we want it to attach to the platform and have it experience the same movements as the platform. So, but if we expand our thinking a little further, we'll want, let's say there are a bunch of cubes falling, one of them falls on our platform, and then one cube lands on another cube. We still want it to move with the other cubes in the platform, but it's not impacting the platform itself. So how are we gonna make this attachment spread from the platform to cubes that land on it to cubes that land on that cube? Well, again, it's pretty simple. If you click your platform here, look over at the inspector and scroll all the way up to the top this time, you'll see that right under the name, right under platform, there's a tag. And every object has a tag. You can change it in the editor right now, and you can change it during runtime. You can also add tags. Basically, we can use the tag of an object. We can check that in the onCollisionEnter method to check if we are colliding with the platform or another attached cube. And then what we can do is when that happens, we can pass on the attachment by changing the cube's tag. So let's get started. We go to our cube, we go to tag, untagged, click that, and then click add tag. It brings you to this tags and layers list. In our tags list, let's hit that plus button and hit, well, let's call our new tag attached. Then we save it. And right now, the only thing that we want to start out as attached is the platform. And then basically everything that hits the platform will kind of inherit that attached tag, like a plague. So the way we can do that is in our block script, in onCollisionEnter, we can check whether the object we collided with has the tag attached by referencing collision. Remember, that's the parameter. Collision dot game object, and this basically is a reference to the object that we collided with. I'm not exactly sure why it's a attribute of collision, but Unity does what Unity does. So yes, collision.gameObject, that's the object that we collided with, and we can use this handy method .compareTag, which will return true if the game object's tag is the same as the one we put in these brackets. So if we put attached here, this if statement will trigger when we collide with something and the thing we collide with has the tag attached. And so what do we want to do when we hit something that's attached to the platform? We want to attach this object to the platform, and we can actually change this object's tag through the script, and we can do that by referencing gameObject. And this is it's not a class. GameObject is a class, but it's with a capital G. So if we use gameObject with a lowercase g, that is a instance variable inherited from MonoBehavior. It basically refers to the object that this script is attached to. So gameObject, essentially think of it as like this.gameObject. GameObject.tag equals, it's simple as that, attached. And boom, the flag has been passed. Now, of course, this tag won't do anything on its own. We need some way to track which blocks have been actually attached to the platform and then to move them. And that's going to be pretty simple too. So up here we can see the platform controller we were working on before, that platform controller script. Let's go back to that. Now, we are going to need a way for the block script to reference the platform controller script. And because there's only one platform controller script and we need other scripts to be able to access it from anywhere, maybe you guys recall if you took from the second year software engineering class, we're going to use the singleton design pattern. Actually, I don't know if that's if we can technically use that term here, but anyways, we're going to have a public static variable of type platform controller, which will be platform controller, which we will call instance. And this will be the one instance of platform controller that exists in the game, because we can have many blocks, but we can only have one platform controller. And how do we set this? Because right now it's equal to null. Well, remember start is called in the first frame. We could say instance equals this in start, except the problem with that is that if we have code in other scripts in the start method that needs to refer to the platform controller instance, it might not be able to, because the order by which start is called on different game objects is not like guaranteed, like it can be random. So what do we use? We used another built-in method, void awake. And awake is basically like start, except that it is called before start. So in awake, we can type instance equals this. And now we have set our singleton. We can go back. Well, actually, I suppose before we go back and edit block any further, let's give our platform controller, let's give it a reference to all the blocks that it has attached to it. And we can do that by giving it a list. So let's make a private list variable. And C# lists are very nice. You just do list and then the triangle brackets here, list game object, because we want it to be a list of blocks. Okay, that's a little annoying. And let's just call it attached blocks. And again, right now it's equal to null. So in start, we're gonna initialize it. Attached blocks equals new list game object, and then open close circle brackets. So now we need some way to add blocks to the list. Why don't we add a new method here, beyond update. Let's just make it public so that other scripts can access it, and call it public void add block. Or let's say add attached block. Let's be specific. It always helps to be specific. And in the as a parameter, we'll take, wow, okay, well, code suggestions work sometimes. Game object attached block. Or why don't we just call it block? Keep it simple. So in here, yep, attached blocks dot add block. And then let's have a companion method, public void remove attached block. And with lists in C#, it's as simple as .remove block. And it will remove it from our list. Now, again, we don't actually do anything with these blocks yet. What we want to do is whenever the platform moves, we want each of these blocks to also move, right? So let us simply go back to over here where we apply our movement, and let's do a little for each loop through our list of blocks, and we can apply the transformation to each of them individually. So one of the major ways in which C# and Java differ is that a for each loop is simply written like this: for each, and then in the brackets, game object block in, nice use of the keyword in there, in attached blocks. And now we can do the same thing that we did here, except instead of, we can just copy this whole line actually. Instead of transform.position, because remember transform refers to the transform of the object that this script is attached to. It's basically this dot transform. We want to do block.transform. And then we can just paste there, block.transform.position plus equals blah, blah, blah. And then same thing, copy and paste that. In the right movement segment there, and then we can just go ahead and remove the minus in order to move them to the right instead of to the left. So let's save all that. So we have all of the block movement code written now. All we need to add is we need to go back to our block script, and we need to make it so that when a block impacts the platform or another attached block, it adds itself to that list of blocks in platform controller. So remember, we created a public static instance variable for platform controller. We can reference that by going platform controller dot instance and then dot add attached block. This. Certainly. Oh, it's good. Take a look. Yeah, game object block and attach blocks. It's really nice. Like, I forget what the syntax was in Java. Actually, I think it might have even been simpler in Java. It was just like for, and then your identifier, and then a colon instead of in, right? But this is like, you know, it's nice and readable. Attached block, or attached blocks like the list, that is right up here. Private list game object attached blocks, and then make sure to initialize it in start. So yeah. Anybody else have any questions? Nice time to pause. Yeah.
So in line 24 in the block class, shouldn't we add like game object instead of this? Like
yes, you are right. I think I was going to write this dot game object, which is the same thing basically. But yeah, we'll get to that. Anybody else? Any questions? All right, guess not. Well, I suppose we're good to continue. Let's visit our block class again, and as discussed, let's change this to game. Oh, not where I clicked. Let's change this to game object. And again, you can also use this dot game object. It's interchangeable. And then we're also going to want to know when the block detaches. Like, say if a block, you know, wobbles and it falls off of our platform, or if it falls off of an attached block, we want it to stop experiencing the same movement that the platform is. So we're going to want to make use of that remove or that platform controller dot remove attached block method. So there's yet another built-in handy method for that. We can use public void on collision exit, and then it's the same thing, collision, and this gets called whenever the object that the script is attached to basically like uncollides with something. So when it falls off of another object, this will get called rather than when it impacts it. And then we can just copy this whole block right here from on collision enter, paste it right in, because we still want to check if the object that we're falling away from is an attached block or the platform. But instead of changing our game objects tag to attached, we can just set that to nothing. Oh, actually, wait. No, that's not right. You're going to want to set it to untagged. If you try to set a game object's tag to a tag that doesn't exist in that list of tags, that list of defined tags that we saw earlier, then you get an error. So untagged is one of the defined tags, so we use that. Although theoretically you could use basically any of the other tags that aren't attached, but anyways, you want to set your tag to untagged, and then instead of add attached block, we want to use remove attached block. And now this should actually be all of the functionality we need for the main gameplay, just like that, in only, what, 80 lines or so? Let's actually just go and test it. Let's see if it works. So what we're looking for is that the platform can move left to right, except the cube, once it lands on the platform, it will move left and right with the platform instead of just resting kind of suspended in space as the platform moves under it. So let's go back to our editor, hit play mode. And, all right, the cube has landed. The cube has made contact. And just like that, it functions. Whoa! Nice. Excellent work, everybody, for making this far. Now, we want this to be an actual game, and an actual game has to end. So, well, first of all, let's add the cube spawning mechanic. Let's make it so that cubes can spawn on intervals from the top of the screen and then fall to the bottom of the screen. Why don't we create an overarching game manager script to handle that for us? It'll just handle just all the overarching workings of our game here. So let's right-click in our hierarchy, create an empty object this time, and let's call it Game Manager. And let's go over. You can see it has no components except transform because it's empty. It was an empty object. Let's hit Add Component, create Game Manager, new script, create and add. Let's wait for that to load. You'll actually notice here that in our project assets folder, this is where all our scripts are being created, by the way. You can see we have block, platform, controller, and game manager, which we just created. It is a script, but the icon is a gear instead of a little C# file. And that actually doesn't mean anything at all. It's just that some icons are reserved for certain script names in Unity for some mysterious reason. And it just so happens that, you know, probably every game that you'll create will have a game manager script. It's just a nice little icon to help you differentiate, I guess. On this game manager object we created, we want to add a component and then game manager and add it there, and then you'll see it show up. All good? All right, let's get to it. Let's hit those triple dots on the right, hit edit script. And again, we get our default script here. So let's see, what do we want to do? We want to add a couple variables to describe the way that our blocks are going to be spawned. Let's have a public float. Let's call it spawn interval. Let's make it 5 seconds. Actually, you know what? Why don't we spice it up? Let's have a minimum and maximum spawn interval, and then have like a random value between it that we wait every time. So it's not like every 5 seconds like clockwork. There's a bit of variation, a bit of spice to it. So let's call it min spawn interval. Let's set it default to 3, and max spawn interval. This is actually something I believe that differs between C# and Java. If you're declaring 2 variables on the same line, you can actually set them both to different values, which is cool. It's a little, but it's handy. And let's see. We're gonna want, well, the way that Unity handles spawning of objects is essentially well, actually, let's go back to our editor. We're gonna need to take our cube here, this cube, because this is what we're gonna want to be cloned. The way that we can clone an object in Unity is, let's grab our cube here from the hierarchy, just grab it, and then drop it into the assets folder somewhere. And what that creates is it creates a prefab, which, as you can see here, cube prefab asset. This basically is kind of like the schematic for our cube. And whenever we want to create a new cube in the game, like through a script, we want to summon new cubes, we reference this schematic to create them from. We can actually, if you drag this into your scene, you'll get a copy of the cube. You can see that the cube in the hierarchy, the name is blue now, and what that means is that it's either a prefab, it's like an instance of a prefab, basically, an instance of that schematic. So yeah, let's delete it. And while we're at it, let's delete our original cube, because now that we have the prefab, we don't need it anymore. So let's go back to our script, game manager. We're gonna need a reference to our cube's prefab. So remember that public variables, we can access those in the editor through those like little fields. So let's create a public game object. Let's call that cube prefab. And when we spawn in the cube, we're gonna want to tell it where to spawn, right? So we won't need to worry about the Y value, because when we spawn the cube in, it will take the Y value of the cube prefab that we created. So it's already going to spawn at the top of the screen, but we're going to want to change the X position of the cube. So we're going to want to shift it left or right randomly so that it appears at a random spot on the top of the screen, right? So let's add a public float. X range. And that'll represent like the kind of radius left and right that we could spawn the cube in at the top of the screen. And the way that we can set that is, well, first of all, let's go to back to our editor. Let's go to our game manager object. And you can see we have all these new fields. We can edit the spawn interval if we like. We can edit the prefab. We can edit the range. So we're going to need to supply it with the prefab, which, as you can see, it's none now. If we tried to clone from this reference, it would give us an error because we have no schematic we're referring to. So let's just go to our assets folder, grab the cube prefab, and drag it right in and drop it onto our field, just like that. And our X range, we don't want it to be 0. The way we can figure that out is, let's look at our game view. So the game view, basically, it'll define the size of our screen. Right now we have, up in the corner here, the game view, it says free aspect. So that means that the play view will fill basically any area that you like resize it to, which is not ideal for like planning things having to do with like screen size, like the X to Y, like left to right bounds of the screen, because if the left to right bounds of the screen are always changing, then we can't really set a variable to define them. So we can just click free aspect here at the top of the game view and change that to, say, 1920 by 1080. And that will just restrict it so that it's the same aspect ratio wherever, like no matter how we resize the screen. And then when you actually export the game, there's a way to, there are ways to handle different aspect ratios. There are ways to lock aspect ratios, but we don't need to worry about that just yet. So let's grab our cube prefab, drag it into our hierarchy, and let's mess around with it a bit to find the bounds of our screen. Let's bring the y value down so that it appears in our game view. There it is, ascending from the sky. And then let's move it around on the x-axis. So if we move it all the way to the left, just so the left side of the cube is hitting the left side of the screen, that's about let's say minus like 12.8. Yeah, perfect. Let's excuse me, a bit of a catch in my throat. Oof. Yeah, actually we'll need to take a bit of a water break. All right, well. Okay, hold on just 1 second. I don't have a coughing fit on the mic. I'll be right back. All right, thank you for waiting. So let's copy this this value. For me, it's minus 12.8. For you guys, it might be different, but I'm not sure. You can copy that. Go back to our game manager and let's set that as our x range. Let's make it positive. 12.8. Basically, that'll mean that we'll be spawning our cubes from anywhere between a minus 12.8 and plus 12.8 on the x-axis. And let's delete our cube and get to the actual code for cloning that cube. So, since we're spawning these cubes on an interval on a timer, we're going to need something to keep track of time intervals. And again, there are a bunch of different ways to do that in Unity. We could declare like a timer variable and reference Unity's. If you remember time.delta time, there's also time.time, which tells you how much time has passed since the start of the game. But we are going to use again the simple dirty method. We're going to use something called a coroutine, which in Unity it comes in very, very handy at times when you need to separate stuff by intervals of time. The way that we create a coroutine is basically we just write a method with a return type IE numerator. And let's call this spawn blocks. No parameters necessary. Now you'll see that we got ourselves an error. We got ourselves a red underline, and that's because in order to have an IE numerator method, it needs to return an IE numerator, and the way that we do that is by using the yield keyword. We don't have to worry about it yet. What we will do first is make an infinite while loop. Yeah, usually a no-no, but here we are going to leverage the power of coroutines to make it so that at the end of each iteration of this loop, we will wait an amount of time in the game before returning to the loop. So it's not going to freeze the game. Don't worry. We will type yield return. See, it's suggesting yield return null. That will wait for 1 frame and then return back. We want to wait for a amount of seconds between 3 and 5. And the way we can do that is yield return new, wait 4 seconds, and then it'll wait however many seconds that we put in the brackets here. But we want a random value between 3 and 5, and we can use, again, really simple, random.range, min spawn interval, max spawn interval. And so now, this code, whatever code is here in the while loop, will execute every random interval of time between 3 and 5 seconds. So of course we haven't written any code in here yet. My throat is very dry. I'm sorry. All right, that's better. So we want to leverage this cube prefab we have to clone more cubes. We can do that by instantiating, using Unity's built-in instantiate function, which creates an instance of a prefab. We're going to want to capture this instance in a new variable. Let's call it GameObject block, and then equals instantiate cube prefab. Just like that. And of course, we want to randomize the x coordinate of this block between the values we set here with x range. So we're going to do block.transform.position equals new vector 3 in order to change its position. The x value, we will use random.range again. Random.range, negative x range, and positive x range. And don't forget the y and z values. We'll just keep those as block.transform.position.y and block.transform. Oh, you ever get a catch in your throat? You just have to cough, like for no reason. You just feel like you have to cough. I'm having that right now. Oh no. The worst timing possible. Just go. All right, I'm gonna go for it. Give me a second. All right, that should buy me a little more time. So we got block.transform.position.y and block.transform.position.z, and so that will preserve the original y and z coordinates the block spawned with. All right, so this coroutine, we haven't actually called it yet, so it's not gonna do anything presently. We can actually, we're gonna wanna call it right from the start of the game, so we can go to our start method, and in order to call a coroutine and make it, work properly, we can't just write like spawn blocks. That will do nothing. We need to use the special method start coroutine, and then within the brackets of start coroutine, there we call spawn blocks. And for the record, coroutines, like IEnumerator methods, can have parameters if you want to pass them in there. It's very handy. So let's go back to our game, our editor view, and let's see what happens. Let's give it a play. Let's see if our work has borne fruit. Whoa, there's a cube. Do we see another one? Oh, we see another one. Okay. Now, you know what? Why don't we test? Okay. Whoop. Well, that wasn't supposed to happen. Yeah. Whoop. Now, as you can see, we've clearly run into some kind of bug, because this is not how physics work. So, I actually panicked for a second because I didn't know what the bug was, and then I thought about it, and now I know what it was. Yeah. Let's go back to our block. In our onCollisionEnter, we add a block to a list when we add the block to the list of attached blocks when it impacts another attached block. So if a block that is already attached hits another attached block, then it will add itself to the list again, which means that the movement will be applied to it in the for each loop multiple times, making it go way faster than it should go. So we can just fix that by doing if the collision object is labeled attached and our game object is not labeled attached. So GameObject.compare tag. Oops, not that. What did I just do? I can't undo it. Oh, that's because I'm hitting Alt Z instead of Control Z. That was epic. Yeah, I'm used to Mac. I know I have nothing to say for myself. So compare tag attached, and we want to make sure to negate that because we only want to apply all this if the block isn't already attached. And let's copy that. And in onCollisionExit, we want this to only trigger if the block is attached. So just take away that negation. All right, that should fix that. We did notice a couple other things while we were playing, while we were testing that latest code we wrote. We noticed that our those cubes were falling mighty fast, and it might be a little more fun if they were falling slower and we had more time to, you know, like go around and catch them. So first of all, let's bring our platform to the bottom of the screen, which we can do. We can just click the platform in the hierarchy, grab that Y value and drag it down. That'll make it, you know, give us more time to see the cubes coming. And so basically, since the cubes themselves are physics objects, they have rigid bodies on them and they are affected by gravity, they will pick up speed until they reach, you know, terminal velocity, which means they will fall really fast. So we need some way to limit their velocity. We could, of course, change the gravity, but that would be a bit of a messy solution because the cube would still, you know, accelerate. And in a game like this, you kind of expect it to, you know, like fall at a pretty constant rate, so you can, you know, adjust the way you move your platform to, you know, catch them in time. So what we're gonna do is, again, a really quick and dirty way to handle this issue. We're gonna set a value, and then we're gonna just clamp the cube's rigid body velocity value, which defines, you know, how fast it's moving. We're going to clamp that velocity value under the value that we set to keep it, you know, consistent. So let's get rid of our cube here. So this variable we're going to need to reference from the block class, but we want it to be kind of like, you know, like ubiquitous. So let's make it a static variable. So let's just make it a in game manager here, you know, just keep all our centralized stuff centralized. Let's make it a public static float. Max velocity, max block velocity. Or wait, hold on. Naming conventions. Max underscore block underscore velocity. And let's set it to minus 3. I'm feeling minus 3 right now. Now, since this isn't a well, it is a public variable, but static variables, whether they're public or not, will not show up in the editor under the inspector in the field. So you'll have to go to your script to change them. But they are static variables, so hopefully you won't be needing to change them very often. So let's leave it at minus 3, and then under block. So we could use the update method for this, but that would be slightly foolish because there's a better way to do it. Basically, update is called every frame, right? Except Unity's physics system actually does not run at the same frame rate as the game. It has its own tick rate, and if we use the yet another useful built-in method, fixed update, this actually triggers at the same rate as the physics ticks do, as the physics system does. So every time the physics system updates the velocity, we are going to check the velocity and clamp it. So first, we need a reference to the rigid body component. And this is going to be our first usage of a very, very common function that you'll be using a lot of the time if you continue to use Unity. Basically, let's declare a variable here, rigid body, RB, since we'll need to reference it. And now, since it's null right now, we're going to need to initialize it. And we can get the rigid body component that is attached to our block in the Unity scene view. We can get that rigid body component by using the method RB equals get component rigid body. And yes, get component is like, equivalent to this dot get component. It gets the component that you define within the triangle brackets here that is attached to this object. And there are plenty of different useful permutations of it. You can do get component in parent, which, like, if this object has like a parent object that has that component, it can find it. You can do get component in children, which it searches all the child objects to see if it can find a component of this type. Anyway, this will get a reference to our rigid body. And then in fixed update here, we can check if RB, that's our rigid body, dot velocity, dot y, is smaller than or equal to, where do we define our variable? Game manager dot max block velocity. Then we are going to set our b.velocity equal to a new vector 3, because velocity is also a vector 3. It has, x, y, and z velocity. We're going to want to leave the x velocity untouched. And then in the y velocity, we're going to want to set it to game manager dot max block velocity. And then keep the z velocity as it is. And it's as simple as that. Now our blocks will not accelerate forever. They will reach a nice little limit that we set. So, one thing that I did forget to do earlier, if you remember when we tested the game last, the blocks were kind of bouncing all over the place, and they were actually bouncing not only left and right, but also like forward and backward off of the platform. And since this game, it's made with 3D objects and 3D physics, but we only really want the physics to be working in 2 axes, right? Like we don't want our cubes to be able to move in the Z, right? Like we don't want them to be moving and rotating forward and back. So we can actually go to our cube here. We can go to its rigid body, and we can look under constraints to fix the position in the Z-axis. And that will make sure that it never moves forward or backward, only left, right, up, and down, which is what we want for our purposes. So I realize we only have 3 minutes technically left in the workshop. We are very, very nearly done. Let's just check out what we have so far. We can move our platform, and look at that. The blocks come down nice and slow. Very gamey. Oh, will we make it in time to catch this one? Oh, thank you. You're too kind. Oh, that one fell. But what's this? The game's still going. We want the game to end when we drop a block. So you know what? Let's, well, I don't know if you guys are willing to stay an extra couple minutes. We will finish this up. Finish this game up once and for all. We will. What? Oh, come on. We already lost. So, all right, here. So we're going to go to our game manager. We're going to go to the script, and we're going to add a new variable here, another public float. We're going to call it y_limit. And this will be, oh, wait a second. Yeah. Wait, we'll make it a public static float because the block class will need to access it. So let's make it public static float y_limit. I love the naming conventions for static variables. And we're going to need to check really quick. Go back to our editor before we finish that up. Drop the cube in, make sure we're in game view, and let's see how far it needs to go down before it hits the bottom of the screen. Let's make sure it's all the way off. Minus 7.75, let's say. Let's get rid of our cube. Go back here. Equals minus 7.75. Oh, one thing that's annoying, one little annoying difference from C# and Unity is that whenever you use a literal decimal, you have to put an F at the end to indicate that it's floating point. Actually, wait, can you use a D to indicate it's double? No, okay, you need an F to indicate that it's a floating point. I don't know, I'm not exactly sure why that is, but you just learn to accept it. So let's go to our block class, and we could do it in update or fixed update. Here it doesn't really matter because fixed update is also, checked often. Actually, yeah, fixed update is checked every time the block moves. So let's have another if statement. If transform dot position dot y is smaller than game manager dot y_limit, then we want to enter a game over state. So what can we do here? Well, the first thing we can do is we can well, you know what? Since this is game over, that's a pretty classic, overarching kind of mechanic. So let's go back to game manager for this. Let's well, actually, you know what? I guess we don't really need to, but it's good practice. Let's add a real quick singleton for game manager. Remember, we did that by doing public static. Last time it was platform controller. This time it's game manager instance, and then void awake. This is the built-in awake function. Set instance equal to this, and then we will go back to block, and then reference game manager dot instance. Oh, I guess we need to add a new method to game manager. Let's add one here at the bottom and call it in game manager. Let's call it on game public void on game over. So game manager dot instance here in block, we're going to call it on game over. And the first thing we can do really easily is we can make the game pause. We can make it so no more blocks are spawned and all the blocks freeze, so the game is stopped. And we can do that by doing time.timescale equals 0. And again, this is really handy. This is time.timescale basically controls the rate at which like physics ticks, well, in like the game view. So if you set it to like 0.5, then everything will go into slow motion. If you set it to 0, everything will pause. So now that the game was over, we do want, as the very last thing to add, we want some way of telling the player their score. So why don't we tell them how many blocks that they've collected. Well, first let's think, how are we going to tell the player anything? How are we going to convey them some kind of message? We could print it in the debug console here at the bottom of the screen. I forgot to cover that, but that's also something that comes in handy a lot. You can type debug.log and then any value you want, and it'll log that to the message, or it'll log that to the console window in the Unity editor, so that you can track stuff while you're testing the game. It's very handy. But if it were an actual game, the player's not going to be able to see the debug console, right? So let us, as the very last thing we're going to do here, let's create some UI text. Very fancy. We're going to go back to our hierarchy, go back to our editor in the hierarchy, right click, and then down under UI, we're going to click text mesh pro, and that's just a fancy way of saying text. So we're going to click that, and you'll notice that this window pops up and it says, well, you need the text mesh pro essentials in order to import text. And let's just click that. And while that installs, basically, yeah, I used Unity way back in the day, and it used to have two different text options. One was basic text and one was text mesh pro. And a text mesh pro by all means should have been the default, because there were a whole bunch of like issues with like text scaling and stuff. It was a real pain to use the built-in text. And at some point they just removed the built-in text option. You can only use text mesh pro, but they didn't really change it so that text mesh pro looks like a default, like it's qualified as like special, like it has text mesh pro, but there's no like regular text to distinguish it from, so it's kind of a relic. Anyways, just a fun little fact for you guys. So now you can see that it has created for us a canvas along with a text mesh pro object. A canvas, basically, all of the stuff that shows up on the game's UI is going to need to be under a canvas. But for now, all we need to worry about is the text. Right now, it says new text, but it doesn't seem to be showing up here on the screen, and that's, I think, because it's white text and it's right in the middle of the screen on the white horizon. So if we change the color, yep, there it is, new text. So, thank you. Let's you can see here under text mesh pro text, you can see all these settings. Let's make the font size, let's blow it up, let's make it huge. So the text is getting crazy warped. Let's fix that by scrolling all the way up here, and you can see we have a rect transform. All canvas objects have a rect transform instead of a regular transform. Pretty crazy. But all we need to worry about is that we need to increase the width. so that, we have a nice amount of space there for the new text. Then let's, we have a nice bunch of formatting options here. Let's make it centered. Let's make it centered, and yeah, let's type in an example message here. Game over. I can make it say big loser, actually. Big loser. You got N blocks. We're gonna an important thing I think in games as small as this is to motivate the player by telling them their score so that they can try to beat it the next time. It's a very nice motivating factor. It adds like surprisingly a lot more fun than you'd think. So we need to figure out how to change this message through a script once the game is over. Let's make the text empty right now, and then let's go to our we haven't saved our scene at all this entire time. That could be very dangerous. You can see that it's unsaved because of the asterisk next to sample scene here. And you just hit Control S and that scene saves, just for the record. So let's go back to our Visual Studio, or my Visual Studio, your IDE of choice. And in Game Manager, first we're going to need a reference to that text. And it's a little funky. In order to reference UI stuff, we sometimes need to use some extra libraries. So we're going to be using, up at the top here, TM Pro. And that's built in. That stands for, of course, Text Mesh Pro. Then let's scroll down here at the bottom of our already declared variables and add a public. Okay, this is a bit of a mouthful. Text Mesh Pro UGUI. Now let's call that our game over text. We're just going to leave it like that. Oh, semicolon, please. Yep, there we go. We're going to leave that like that. And then in our onGameOver method, we're going to do game over text dot text equals big loser. You got. Well, now we need to find some way to reference the amount of blocks the player has, which thankfully is pretty easy. Well, pretty simple for our purposes. And this isn't going to be like completely accurate just because we made some allowances in the whole calculating of attached and not attached blocks, in order to make this workshop like, nice and smooth. But it'll be accurate enough for our purposes. We want to get the length of the list of attached blocks, because remember that updates whenever a block attaches or unattaches. So we can use the count of this list as a good estimate to how many blocks the player has on their platform. So we want to change that from private to public. And back in Game Manager, big loser, you got, let's concatenate, platform controller. Remember, we can reference the platform controller dot instance dot attached blocks, because we can reference that now that it's public. And the way we get the count of a list in C# is .count with a capital C. And of course we want to add to that some more string blocks. Better luck next time. So this is all we need for our complete game. The only thing that remains, well, I guess complete is a strong word, but the only thing that remains is we go to our Unity editor. Remember that text variable, that text mesh pro variable that we created in our game manager. Let's go to our game manager in the hierarchy and make sure that's set, because right now it's set to none. Let's grab our text from the canvas, drop it in there, and you know what? I think it's time to test out our game once and for all. Let's hit that play button. All right, it's officially gaming time. All right, first cube, easy peasy. Second cube, easy peasy, didn't even have to move. Where's the third one coming? Oh, right on top of the first two. Too easy, honestly. All right, where's the next one? Wow, this is just, easiest game I ever played. Oh, wow, okay, well, that's gotta be like pretty improbable. The first 5 would all fall like within a couple inches of each other. Anyways, I'm making a couple nice little stacks here. Something you could do very easily to make this game a little more challenging, a little more fun, is you could add different types of blocks. You could have a list of different block prefabs. Wait, I didn't even realize it was okay. Okay, I'm just gonna offset those. I actually didn't even know it was subconscious. Okay, anyways. Oh, one fall. Oh, big loser. You got 14 blocks. Better luck next time. Thank you. Thank you guys all. So you can see we've got ourselves a game. You know, I'm fighting the urge to play again and beat 14. But yeah, like I was saying, this is a very simple base game. It's very easy to change a lot of the stuff, add features. Like for example, you could have, instead of just the one block prefab, the one cube, you could make like, you know, you could change the cube scale, make like rectangles, make like big huge cubes and little tiny cubes, and then spawn a random one every time a cube needs to be spawned, and then wow, you have something like Tetris. You have a real challenge. But even just with regular cubes, you can see it is fun. And yeah, so that was our little introduction to Unity. You now officially are game developers. Congratulations. Woo! I commend you. So, well, thank you all so much for coming and for sticking out the extra 10 or so minutes. Yeah, I know this workshop was late, so yeah, thank you guys for coming here instead of sleeping. All right, I hope you guys had fun. Hope you learned something. Thanks for coming.
Yo, big thank you
Everybody.
to Max. Everybody, can we get a big thank you to Max for
Wow,
staying
you
this
stole
late?
it. I can't
That's
believe you.
crazy.
Thank you, Max.
Big developer guy right here.
Max, you're actually crazy. How do you just like code?
I don't know. I do it a lot actually.